Now consider our Science 1 Chapter 1 Gravitation exercise question number 2D on page number 15. A stone thrown vertically upwards with initial velocity u reaches a height h before coming down. Show that the time taken to go up is the same as the time taken to come down. See this diagram. Initially stone is at this position, that is on the ground. Initially velocity u, it is thrown upwards. As it goes up, velocity goes on decreasing. At the highest point, velocity v is 0. Then it falls downwards in the second case and again reaches to the ground. We consider the first case where the stone moves upward. So in the first case, initial velocity u, when it reaches the highest point, velocity becomes, at the highest point velocity becomes 0. So in the first equation of motion, v is equal to u plus at, put v is equal to 0, initial velocity is u. Here motion is vertically upwards, but acceleration due to gravity is downward. So we put a is equal to minus g. So we get u, v is, which is 0, equal to u minus gt. So gt equal to u. Time taken to move upwards is say t1. So put t is equal to t1, and then we get here t1 equal to u upon g. So this is first equation. Now we apply the third equation of motion. V square is equal to u square plus 2as. V 0, u square, a is minus g. So we get, when we put these values, 2gh is equal to u square, u is under root 2gh. Substitute this value of u in equation 1. So from the first equation we get t1 equal to under root 2gh upon g. This g in the denominator can be written as square root of g square. Simplify, you get t1 as under root 2h upon g, that is time required to go up. Now we consider second case. In the second case, stone from the highest position start moving downwards. So in this case, now initial velocity is 0 and acceleration due to gravity downwards, motion is also downwards, so velocity of the stone goes on increasing. In this second case, that is during downward motion, we use the equation s is equal to ut plus half at square. S is equal to h. In the second case, initial velocity is 0. So put here u is equal to 0. Remember, in the upward motion, initial velocity is not 0. Their final velocity is 0. And during the downward motion, initial velocity is 0. So put u is equal to 0. A is equal to plus g, because in this case, motion is downward, acceleration due to gravity is also downwards. Put these values, we get h is equal to half g into t2 square, where t2 is the time required to move downwards from the highest position to the ground. When we put these values and simplify, we get t2 is equal to under root 2h upon g. Now see equation number 2 and 3. Equation 2 is the time required to move upwards. Equation 2 gives time required to move upwards, which is root of 2h upon g. Equation 3 gives us time required to come down. Equation 3 gives us time required to move downwards, that is to come downwards. So by 2 and 3 we get t1 equal to t2. Hence time taken to go up is equal to time taken to come down.